All right, this pre-calc, section P3, linear equations and inequalities. Okay, this is a review for you all, but we should be able to identify properties of equality, correctly solve linear equations in one variable, and then correctly solve linear inequalities in one variable. Okay, back in geometry, and I've got this from geometry, we reviewed reflexive, symmetric, transitive, addition, and multiplication properties. Reflexive, it's equal to itself. Symmetric, if u equals v, then v equals u. Notice it flipped. That's why I can set something up and say x is 2 or 2 is x, is equal to x, and it's the same thing. Transitive property, if u equals v and v equals w, then u and w are equal. Okay, so it's that dropping of the middleman. Addition, whatever I add to one side, I add to another. So if u equals v and w equals z, because we're showing that we have the same stuff that we're going to add together, they're equal, then u plus w is equal to v plus z. Multiplication, same idea. If u and v are equal and w is equal to z, and then if I multiply the same value to each side, it's still equal. So here's the deal. We've got this solving equations, and I'm going to distribute the two. That's going to be 4x minus 6 plus 3x plus 3 is equal to 5x plus 2. The biggest problem with doing these is just making sure when you distribute, you multiply both things and you pay attention to your signs. After you do that, combining like terms, 7x minus 3 equals 5x plus 2. And then I'm going to subtract 5x from both sides, and I get 2x minus 3 equal 2. And I always subtract the lowest value that's with the x. That way I get to avoid my sign. I could have subtracted that 7x from both sides, but I would deal with that negative 2x on the right side. Now, since I didn't subtract a 5x and I got everything on the left, I'm going to add 3 to both sides and come up with 2x plus 2x is equal to 5. And divide by 2, and I either have 5 halves or 2.5. I'd like you to give it a try. So turn off the tape and have at it for 1b. Okay, hopefully when you did 1b, you distributed 8y minus 24, 4 times 2y is 8y again, it's minus 24 again, equals 64. So we have this situation. So I've got 16y minus 48 equals 64 after combining like terms. Adding 48 to both sides, you get 112, so I divide by 16 and y is 7. So that's equality review, and it's equality with whole numbers. The next thing we're going to do is work with fractions. Now, solving equations with fractions, we're going to solve the equation, same one, in 2 ways. Now, if I clear out the fraction, I have to multiply by something called the least common denominator, the LCD. And 3, 4, and 2, I just take factors of 3 and 4 and 2, and I'm just borrowing it. I need 2 2's to make a 4. I've already got that with a 2 and a 3, so I got 3 times 4, which is 12, and I'm going to multiply by 12 on both sides, or all the way through it, and able to clear out my fractions. So 3 goes in 12 4 times, so on the top it's going to be 4 times the quantity, t minus 1. 4 goes in the 12 3 times, so on the top it's going to be 3 times the quantity, t plus 5, and 2 goes in the 12 6 times. So when I get that done, this is what it is. Okay, so now I just distribute just like I did above, and I got 4t minus 4, 3t minus plus 15 is equal to 6. And at that point, after I've cleared out the fraction, it becomes a little bit easier of a solve. So I've got 7t plus 11 equals 6, and then I subtract 11, 7t equals negative 5, and t is equal to negative 5/7. But now when I kind of embrace the fractions, I'm talking about embracing them, which means I've got to have the bottom term all the same. So again, LCD is 12, so each one, I've got 12, and 3 goes in 12 4 times, so the top is 4 times quantity t minus 1, top is 3 times quantity t plus 5, and 6 times 1 is 12. They look really a lot alike, but I didn't get rid of the 12, and like I did over here when I multiplied both sides by 12. I could still do that here, but remember I said we're going to keep it. And one of the reasons we're going to keep it is because when we multiply out or divide out a variable in our future, we lose one of our possible restrictions. So it's important for us to realize that sometimes we're going to have to work with our fractions. So this is just a practice. And again, I'm going to do exactly what we did before. We're going to distribute the 4, distribute the 3. So I got 4t plus 4 minus 4 plus 3t plus 15 on top, divided by 12 is equal to 6/12. I'm going to get to the 7t plus 11 over 12 and the 6 over 12. Now, at this point, I'm going to break these up. So I got 7t 12ths plus 11 12ths. So I can combine like terms on the other side. And I'm going to subtract 11 12ths from both sides. And I'm going to come up with 7t 12ths minus 5 12ths. Now, I'm going to multiply by the reciprocal. Okay, I had 7 12ths. And now I'm going to multiply by 12 sevenths. And the reason I'm doing this, remember, division by a fraction is the same as multiplication by that fraction's reciprocal. So I had 7 12ths I would divide by on both sides. And able to do this without my calculator in my hand, I can do this by just taking the reciprocal of 7 12ths and multiplying by 12 sevenths on both sides. Okay, so now when I do that, the 12s are gone, the 7 is gone, so it's going to be t equal negative 5 sevenths. That was the same value that we started with the other side, but notice it's easier if I am able to clear the fraction. And in times, as long as I'm not getting rid of a variable, I can do that with numbers. But if I'm going to be getting rid of a variable and clearing the fraction, or dividing out a variable, I got to avoid it, and I got to keep the variable in the problem to make sure I have all my restrictions there. A lot of times I divide out a 0, which is some sort of restriction or some value in the problem where the graph will cross the axis or there'll be a restriction on the graph itself, and we have to be careful about those things. Now, properties of inequality. So we're going to do exactly what we just did with equality, and we're going to solve stuff with inequality. And again, when I'm looking at inequality, at u, v, and w, and z are be real numbers, variables are algebraic expressions, and c is a real number. Transitive. Well, transitive works the same way. If u is less than v, and v is less than w, okay, then u is less than w. Addition. U is less than v, and if I add something on both sides that's the same, I add w, u plus w is still less than v plus w. If u is less than v and w is less than z, then u plus w is less than v plus z. Multiplication kind of works, this way. We're talking about u is less than v and c is greater than 0, so c is positive. So if I multiply by a positive value, then it stays the same. But if I multiply by a negative value, like I do here in the second one, the sense of the sign switches. Remember, if I multiply or divide by a negative value, the inequality switches its sense or its direction. The sign switches and goes the other way. So the above properties are true if the less than sign is replaced by the less than or equal to sign as well. There are similar properties for greater than and greater than or equal to. So it's real similar, the flavor's there. Just keep in mind it's the same stuff we've done before. It's just review, get it back into your head and dust off the shelves and clear out the cobwebs up there. So let's actually use one. Example 3, solving linear inequalities. Okay, we've got the distribution, and then we're going to combine like terms and solve across. Remember, we treat this just like an equality sign all the way up until the time we multiply or divide by a negative value. So let's get after it. So now we've got 3x minus 3 plus 2 is less than or equal to 5x plus 6. Well, I'm going to get that 5x and the 3x together by, let's combine like terms first. I'm getting ahead of myself. So I've got 3x minus 1 is less than or equal to 5x plus 6. After I do that, I'm going to subtract 3x from both sides. In doing that, I get negative 1 is less than or equal to 2x plus 6. Now I'm going to get the 6 over here. I'm going to subtract it, and then I got negative 7 less than or equal to 2x. Notice I have not even changed the sign because I haven't multiplied or divided by a negative value. And at the end, I'm going to divide by 2, and the sign stays the same direction because it's a positive value I'm doing my dividing by. So negative 7 halves is less than or equal to x. Note to self, when multiplying or dividing an inequality by a negative number, the inequality sign flips. Okay, that's the idea of the sense. So keep that in mind as we're going through. You can just work with it as you're going and just keep in mind what's happening with it as you move through your problem. The solution set in interval notation for this problem is it's closed at -7/2 because of the or equals. But now all the stuff greater than x goes to infinity. So it's an unbounded open on the right side. So solving linear inequalities with fractions, solve the inequality and graph its solution set. So let's solve first. And just like we did before, let's multiply by 12 on both sides. Now clear out the fractions. So I'm going to have 4x plus 6x and 3x plus 4. Okay, and here it's greater than. I'm going to subtract 3x and subtract 6, so x is greater than -2. Now keep in mind the way I do this kind of avoids that negative sign at the end, just because I always go with the smaller and I combine the smaller one with the larger x value. You don't always have to do that. I just know that one of my issues is going to be dropping a sign. It happens a lot, and it's just something I've learned to try to avoid by fixing how I go about doing my solving. Now, x is greater than -2. Well, if x is greater than -2, and it's not or equal, so it's a bracket, or a parenthesis, I should say, not a bracket, a parenthesis, and everything over here to the right is greater than -2. And I put on there, this is a solution set for x. Now, in set builder notation, it's x such that x is greater than -2. Notice the difference. Okay, from my answer to my set builder notation. In interval notation, okay, it's an open set from -2, open and bounded from -2 to infinity. Keep in mind as we're going through these things, the more restrictions I have, the more complicated an interval notation answer for my solution is, and the easier it becomes right in the set builder. Let's look at our next problem in 5. Solving double linear inequalities. We're going to solve the double inequality and graph its solution set. Remember, a double, whatever I do to one side, I do to another. But let's try to make sure this is as clear as, mud maybe. But let's see if this will help. Okay, if I were going to solve this, okay, I would look at this and I go, well, I'd multiply by 3 to get rid of that 3 on the bottom. And if I was going to solve this, I'd still multiply by 3 to get the 3, get rid of that 3. Well, keep in mind, the whole reason I'm here is to solve for that interval for x. So while we're here, let's do it on both sides. I'm going to multiply by 3, positive 3 on both, all the way through. Each term here is going to be multiplied by 3. So I get -9 is less than 2x plus 5, which is less than or equal to 15. Well, again, keeping in mind, if I'm going to do 1, I'm going to do all 3. If this next thing, I'm going to subtract 5. I'm going to subtract 5 from all 3 terms. So subtracting 5, I get -14, less than 2x, which is less than or equal to 10. Okay, and my last thing, well, everything else has been multitasked. Let's do that again and divide by 2 to get the x by itself. So I'm going to divide by 2. I get -7 is less than x, which is less than or equal to 5. What's that look like when I do a number line? Well, I'm looking at this -7 to 5. It's open at -7. It's closed at 5. So I've got a half open set as I'm looking at this. My set builder notation set x such that -7 is less than x, which is less than or equal to 5. Okay, I just put that in there and dress it up in set builder. My interval notation can be open at -7 and closed at 5. And that's our solution. So keep in mind the difference of the two. If you still have questions about them, please ask. If I had said anything that makes it confusing or anything during this notes presentation, please follow up with that, and that way I can try to fix it in the future as well. I hope you guys are doing well, and I hope you're having a great day. Here's the assignment for what we've got going today. It's PreCalc, P.3. We're going 3 through 60 multiples of 3, and we're skipping problem 30 on that. Please make sure you're showing all your work, and we'll see you in class.